Okay, so we are going to talk here about solving two-step equations. So in order to solve two-step equations, there's two things you have to remember. You have to remember what it means to solve an equation. Now, if you've never heard of solving an equation, which Caitlin, I know you have, but that means you need to go back and watch the intro to algebra video that we posted last week. But solving an equation, you have to remember what it means. Caitlin, do you remember what it means to solve an equation?
No.
I forgot all that. It's been 2 weeks. It's been too long. So another way we'll often say when we want you to solve an equation, and this is kind of math speak, but we'll say it means to isolate the variable.
Okay.
Now, I know you know what the word isolate means, because we all have friends who ended up in isolation in jail. Oh, maybe they're not our friends, right? But we've heard about these guys. Okay, so isolate means to get alone. And when I talk about a variable, I'm talking about a letter. So basically to solve an equation means to get the letter alone on its side of the equal sign. Okay, so if I just jogged your memory, I'd like to, do you remember how to solve some of these one-step equations? Like if I had x plus 57 equals 73, would you know what to do to solve something like this?
I don't, minus the 57 from the 57 and the 73.
Absolutely. I'm going to subtract the 57 from both sides. I'm going to do the opposite of what's occurring. The opposite of addition is subtraction. On this left-hand side, adding 57 and subtracting 57 cancels, so I have x alone. And then on this other side, let's see, what would I get? 13 and 3, 16. And I know I'm done now because this letter is alone. This variable is isolated. Okay, great. So we remember that much. The second thing that you have to remember in order to solve two-step equations, anytime in math that I start talking about doing more than one thing, I need to remember that wonderful order that we memorized the other day. Do you remember when we were simplifying and we said that there were some steps that we would take with our operations and we would have an order? Do you remember what those were, that order was?
No.
Okay, it's known as the order of operations commonly. And I taught that class to myself. So I hope that you got a chance to look at the video. If you didn't, you should go back and look at it. Super crucial.
Okay.
But the order of operations says that math is done in 4 steps. Well, simplifying is done in 4 steps. The first step is groupings. The second step is exponents. And by exponents, I mean both the little floating powers and their inverses, the radicals or roots. And then the second step is all multiplication and its inverse. And you know what the inverse or opposite of multiplication is?
Division.
Exactly. And then the final step of the order of operation is addition and its inverse. So you usually end up working addition last. Now, I'm really, really lazy about writing all these steps out. So I will often sum up the order of operations by saying GEMA, groupings, exponents, multiplication and its inverse division, addition and its inverse subtraction. Does that make sense to you?
Yes.
Okay, good. We have everything at our disposal we need in order to be able to solve two-step equations now. Let's put this together. Okay, so the first thing here to realize is that simplifying that's what we were doing when we were doing those order of operation problems with the multiple steps. Simplifying is different from solving. So I'll give you an example of a problem that we might simplify. For example, you might simplify something like this. Okay, so this is a multi-step problem with different numbers going on and different operations going on. But the only thing that I can do here is I can simplify, because this is an expression. And basically, oh, sorry, let me erase that. I'm talking simplifying versus solving. We simplify expressions. Students use the word solving all the time in the wrong way. This problem over here on the left that I just wrote down, this is not something we can solve. This is only something we can simplify. And what I'm saying when I say simplify is I'm saying all we can do here is we can obey the symbols here that have been presented. So there's a few operations that have been indicated here. There's a subtraction, there's this multiplication, there's this power, and all we're able to do is obey those symbols. That's known as simplification. Does that make sense?
Yeah.
Okay, now solving, on the other hand, like that problem we just looked at, you're going to notice that when I start solving, this is not an expression anymore. This is now an equation. It has two expressions and they're set equal to each other with an equal sign. So when I talk about solving, I'm solving equations. And I'm not being obedient in this case. Like in a case like this, if I saw 81 equals 9p, I wouldn't do this multiplication, this 9 times p, because I don't know what it is. Instead, I would do the opposite of what I was told to do. I would divide by 9 on both sides. And so we use that wonderful inverse property. It's like we're working backwards. We're undoing what they told us to do. Does that make sense?
Yeah.
Okay, good. If you can understand that, then it's going to make sense to you that if when we're simplifying, we're working forwards, we're putting things together, we are going to work Gemma this way. But when we are solving, we are being disobedient, we are breaking things apart and kind of working backwards. We are going to work Gemma, the order of operations, the opposite way. That is the only new thing you need to know in order to solve two-step equations. So let's get started with solving some two-step equations based on this. So here's an example. This is a two-step equation. 2x plus 9 equals 37. Now, it's obvious that it's an equation, of course, because here I have this expression equal to another expression. Quite clearly, it's an equation. But how can I tell that it's a two-step equation? Let me just change my color here. Whoops. Can you see that now on the side where x is, I have two numbers hanging out. I have a 2 and I have a 9. And so it's going to take me two separate steps to get rid of both of those numbers. Does that make sense?
Yes.
Okay, beautiful. So we're going to do that. And the only question really is the order in which I do that. And so we said that we would work our Gemma backwards. So that means we are going to take anything that's adding or subtracting first when we start solving two-step equations. So I want to take away this 9 first. And the reason why is because this 9 is currently adding. Just like always, when I'm solving an equation, I'm disobedient. I do the opposite of what I've been asked to do. So the opposite of adding 9 is subtracting 9. And the rule of algebra is I can do whatever I want as long as I do it to both sides. And so there I have my minus 9 on both sides. Okay, now let's look at what our new equation would be if I made that change. I make a balanced change on both sides. That's known as my balanced change. But then I have to rewrite my equation to see what's left after making that change. So after I had been adding 9 and now I subtract 9, those two things would zero each other out. Adding 9, subtracting 9, they just zero out. And so all I have left on my left-hand side is 2x. Does that make sense, Caitlin?
Mm-hmm.
Okay. You look like I thought I was confusing you. Okay, now on that right-hand side, there's the work to do. 37 minus 9. I'm not like coming up with these numbers. I'm just reading what I said I would do. I said I would take 37 and subtract 9. And of course, I am going to get 28. I've been making all these errors in my adding and subtracting lately, and people have been getting on me on the internet about it, Caitlin. So you have to catch me first, okay? So some internet troll doesn't do it, okay? So 2x is equal to 28. Okay, now I'm not done with this equation. Why am I not done with this equation? Because the letter's not yet alone. It's really important, especially for new students, that you don't look back up above this dotted line. Do you see that? I have a new equation. I'm not going to look back to the old equation anymore. So here's my new equation. Now, I, again, am still trying to get the x, the letter, alone. And so now I have to move a 2. And so I always move something by doing the opposite of what's happening. Right now, this 2 and this x are shoved together. And so meaning that they're multiplying. And so I'm going to do the opposite of multiplying. I am going to divide. Opposite of multiplying is dividing. Again, you can do whatever you want to an equation as long as you do it to both sides. So I jump the equal sign and I do it over there as well. Okay, let's see what happens. On the left-hand side, 2 divided by 2, timesing by 2, dividing by 2 are opposites, so they cancel out. And I have just an x here. And there's the math I'm going to do. I say I'm going to take 28 and divide by 2. So 28 divided by 2 is 14. And now I know I'm done because the letter's alone. Is that good?
Yep.
Okay, we'll start moving a little faster and look at some trickier examples. Have you ever done anything like this before?
In high school.
In high school? Been a while? Did it make sense then?
Yeah.
Okay, just it helps me decide how fast to go.
Yeah, it's just like I already had, when you said I looked confused, I already worked the problem out. Was doing.
Cool. Okay, so a lot of times the GED will freak you guys out by putting what looks like fractions into an equation, but it's not necessarily a fraction problem, okay? So would you know what thing to take first this time?
Yeah, is it subtract 20 from each side?
Exactly right. We take anything that's adding or subtracting first because we're working our gemmas backwards, our gemma backwards, our order of operations. And so yes, I will subtract 20 from both sides. So on the left-hand side, if I subtract 20, I'm going to get 5. I should let you tell me what I'm going to get. And on that right-hand side, if my positive 20 and my negative 20 cancel, what is going to be left over here?
M over 2.
M over 2. Now this is where students freak out, but hopefully you won't after our first lesson. Do you know what to do now to get rid of this 2?
Do times it?
Absolutely. Right now that 2 is dividing. That fraction bar means the same as divide. And so I can do the opposite of dividing, which is multiplying. And I'm going to do it like a mathematician with parentheses. I'm not going to do it like a third grader with a little times sign, or I'm going to get confused in higher math. And so it stresses some students out because of that multiplication on either side. But I put it in a different color so that you can see the change there. And 2 times 5 is 10. And then on this side, dividing by 2 and multiplying by 2 cancel so that my M is alone. Cool. How's that one?
Good.
Easy, yeah?
Yeah.
Okay, sweet. Then let's look at some even trickier GED examples here. We're going to finish up so fast because you're so zippy at this. So I want to look at one that I can usually freak students out with. Okay, so students lose their mind here. They just don't know what to do. And maybe you do, but I really want to talk about the why really quickly. So remember I said when we're solving, we're working our gemma backwards. So then there's a lot of students who tell me, well, we better then move this subtract 15 first. However, we learned when we did order of operations that fractions naturally give us 2 groupings, a top grouping and a bottom grouping. Does that make sense? We have a group on top and a group on the bottom?
Yeah.
And so since we're working gemma backwards, I'm actually going to save that grouping for last. So I'm going to let this P minus 15 group here, this group that P's in, just stick around. I'll save that for last. And the first thing I actually want to get rid of is this 7. Now, what is this 7 currently doing? Well, this 7 is currently dividing. And so I'm going to do the opposite of divide. I'm going to take this entire ugly thing, I don't care how nasty it is, and I am going to multiply by 7. Now, I want to talk about why this works. If this entire nasty thing is dividing by 7, of course, the opposite of dividing an entire thing by 7 is multiplying an entire thing by 7. Does that make sense?
Mm-hmm.
Okay, you can do whatever you want as long as you do it to both sides. So I'm going to jump the equal sign and do the same thing to the right-hand side. On the left-hand side, multiplying by 7 and dividing by 7 will cancel. And all that I have left is my P minus 15. And then on the right-hand side, there's the work I said I would do, 2 times 7. So 2 times 7 is 14. I'm almost done now. Pretty clear to see what I need to do since I'm not looking back up at the old equation. P is still not alone, so I will add 15 to both sides. Let's see how that changes the left and right-hand side of my equation. On the left-hand side, I'm left with P. On the right-hand side, I'm left with 29, and I meant to have my other color fired. P equals 29. This is my new equation, and I know I'm done because the letter's alone. Is that good?
Mm-hmm.
Last one. The operations don't have to be add, subtract, multiply, divide. They can get a little more complex, okay? Right now, we see a couple of things going on with M, okay? A couple of operations that we need to get rid of. This M is being multiplied by 3, but it's also being squared. Can you see that?
Yeah.
Okay, according to the order of operations, which you remember I'm working backwards, what should I work to remove first?
The 3.
Absolutely. The 3 is a multiplier, so it's going to come before an exponent if I'm working the order of operations backwards. And so I'm going to do the opposite of timesing by 3. I'm going to divide by 3. Okay, wonderful. On this side, multiplying by 3 and dividing by 3 cancels, so that my M squared is alone. And on the right-hand side, I'm going to do some sight division. 3 goes into 4 once, remainder 1. 3 goes into 18 6 times. And so I get M squared is equal to 16. Are we cool with that?
Yeah.
Now, a lot of students stop right here. They're like, the letters alone. And it's not really technically a number there. It's an operation, but still that letter is not alone. It is being squared right now. We need to get rid of that square so that the M is really isolated. And so I have to do the opposite of squaring. Do you remember what the opposite of squaring is?
Mm-mm.
Yeah, a lot of students forget that. So let me just write down a little cheat sheet over here about inverses. The opposite of add, of course, we know is subtract. The opposite of multiply is divide. But the opposites of powers, like the square, are their roots, like the square root. So you only see square roots and cube roots on the test. But either one of those could show up. Fair game, okay? So since I'm trying to get rid of a square, what I'm going to do is the opposite of square. I'm going to take the square root of both the left and the right-hand side. Is that cool?
Yes.
As my balance change, I'm doing it to either side. Notice I write it right on that line because I want to take the square root of that stuff. So on the left-hand side, squaring and square root cancel so that I do have just an M by itself. And on the right-hand side, there's the work to do. The square root of 16, I'm asking what number times itself equals 16. And of course, we know that that is 4 because 4 times 4 is 16. I'll just make a little note of that. What number times itself equals 16? And so my answer here is M is equal to 4. And math like this very commonly comes up when you're working the Pythagorean theorem. Okay, so it might happen in your solving equations, but it might also happen in your geometry problems. Okay, do you have any questions about this one?
No.
Sweet. I think that's as complicated as my two-step equations get. Okay, so I do have a few homework assignments for this. So I'll put up a beginner level, which just has whole numbers. And then we'll have a more experienced level, start looking at those decimals, those integers. And then the most challenging level to these actually is being able to translate them into word problems. And the GED does have algebra problems, and they're very fond of using two steps for this, where you have to read a word problem and translate it into the language of algebra. And we are not used to that. We are used to just using arithmetic to solve two steps, because why bother with algebra if it's just two steps? I can probably figure it out with arithmetic. But nonetheless, they want you to have that skill. So for those students who are really looking for that GED style challenge, and for you, of course, Caitlin, I will post the word problems as well. Do you want me to work a word problem so you can see what I mean before I end?
Sure.
Okay. Now I have to come up with one off the top of my head, right? Okay, so let's say that Jerry had $97 in his bank account at the start of summer. He did yard work all summer for $15 an hour. And now has, and since I'm just coming up with things on the fly, you're going to have to forgive me for a second as I make sure it's a number that works. $982. Okay. Write an equation that could be used to solve for H, which represents the number of hours he worked. Okay. Now, the good news is if you really did get this on the GED, it'd probably be a multiple choice. So you could use some of your multiple choice skills to kind of sort out which one it is. But I'm just going to do this from scratch here. So let me pull up a different color and let's take a look at this. The most important thing with when you're writing an equation is to know the thing you're looking for. The thing that you're looking for is the mystery, and it's going to be the letter. Now, this particular problem that I wrote, they were really straightforward. They told you what the mystery was. They even gave you a letter to use, okay? They said that we are going to be solving for H, and H is the number of hours he works. So we're going to use the letter H every time we want to talk about the number of hours this dude worked. This is just my little note to myself. From here on out, I'll remember that every time I use H, I mean number of hours. Is that good?
Mm-hmm.
Okay, now I'll write the equation. Now that I know what letter I'm using, now I'll write the equation. Remember what an equation is. My husband is an 8th grade math teacher, and I was just helping him grade papers the other day, and it made me really sad because these students were supposed to be writing equations, and they didn't remember what it meant to be an equation. There were no equal signs. So if you don't have two expressions and an equal sign, you don't have an equation. Does that make sense?
Yeah.
Okay, cool. And now an equation, since the two sides are equal, has to be two different ways to talk about the same thing. And so what I can do here is I know the total in his bank account right now. And I also know how he got that total, like how, the process from which that he worked to get to the total. And so that's what I'm going to do. I'm going to talk about the total in two different ways. Now, one way, I just know how much the total is in his account. How much is it, my dear?
$982.
Absolutely. So I'll put that by itself on one side because that's one way to talk about the total. Of course, as you probably know, I don't really need the dollar sign while I do my equation. Now I have another way to talk about his total money. He had a starting amount, right? He started with how much?
$97.
$97. And then what happened? Well, he got some additional money. Does that make sense? He got some additional money?
Yeah.
So I'm going to add on something. Now, how much am I going to add on? The mistake most students do is they just put a 15 here. But if you just put 15 here, you're just making him work 1 hour. He's only earning $15 once. We need to think about the fact that he's earning $15 over and over and over again. How many times is he going to earn for $15? He's going to earn $15 H times, because we don't know how many hours he's working. Maybe that H is a 3, maybe that H is a 37. But he's going to work $15 an hour for some number of hours. Does that make sense?
Yeah.
Now, this isn't the only kind of two-step equation that they might write, but this one is super, 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 super common. It's like a favorite of theirs because just the type of format it happens to be ties in with a lot of other GED questions. Okay. Now, this particular problem does not ask me to solve. It just asked me to write the equation. So if I was really just working this way, I would stop right here. I'm done. This is the equation. Now, if they ask me to write and solve, which happens a lot in math classes, you know, I haven't seen that come up or heard of that coming up on the GED, but you know, I don't actually go take the test. So I'll just go ahead and solve this. So let's give ourselves a little space. What do I have? 97 plus 15H equals 982. Okay, I think I'll just erase this. And let's solve it because I'm a mathematician and I can't help myself. So what would you move first in order to solve this, my dear?
Minus 97.
Absolutely brilliant. I want that 97 to zero out. So I'm going to subtract it from both sides. Even though I wrote those two sides really far apart, I'm going to make sure I jump my equal sign. On this side, positive 97 and negative 97 cancel out. Now, what do I have left? I have plus 15H left, but plus 15H, we never have to brag about pluses at the beginning. So we just drop that and we end up writing 15H. Is that cool?
Mm-hmm.
Okay. And then on that other side, oh my gosh, we better bust out our calculators since I've been internet stupid lately. I get 885. Beautiful. And then final step to solve this, I need to break up that 15 and that H, who are so close, they are clearly multiplying. So I will divide, dividing both sides by 15. And I'm going to come this way, which is rude for my beginner students, but 15 divided by 15 cancels. So I'm left with H on the left-hand side and 885 divided by 15. You'd think I'd know what it is since I just wrote the problem, but I don't remember, is 59. So the dude worked 59 hours. Wasn't really working that hard if you think about it. He probably played a lot of video games during the summer. Yeah. Okay. How's that work? Is that okay?
Yeah.
Cool. Do you have any questions about any of this?
No.
Then we are good to go. And I will post all this up plus the worksheets in our class by tomorrow. Okay?
Okay. All right.
Awesome. Thanks.
Thank you.
Bye.
Bye.